In this video, I will show you how to solve systems of linear equations by elimination. This is also known as linear combination. The key to this method is getting opposites that cancel. So we either need the x's to cancel out or we need the y's to cancel out. So look and see if either the x's or the y's are multiples of each other. For example, the smaller term for the x's is 2x. The larger term is 4x. Notice that 4x is a multiple of 2x. That tells me that this would be a good target. I could easily make these into opposites that cancel. Look at the y's. See how 5 is not a multiple of 3? So it would be more difficult to cancel out the y's. So let's focus our attention on the x's. Now, how could I make them into opposites? So imagine, for example, that we multiplied this top equation by -2. That would give me -4. That would cancel the 4x. So that's what I'm going to do. I'm going to multiply the entire equation, though, all three terms. So that's going to give me -4x plus 6y is equal to -2. Okay, now the bottom equation I did not change, so I'm just going to recopy it the way it is. 4x minus 5y is equal to 7. So once you have opposites that cancel, go ahead and combine the equations into a single equation. So if I combine these, of course these will cancel out just like we wanted. If I combine these, that's just going to give me y equals. And when I combine these, I get 5. So that gives me one of the variables right there, y equals 5. Now I can take this variable, this value, and substitute it back into either one of the two original equations in order to solve for the other variable. So I'm just going to use the top equation. I'm going to recopy it here. So I have 2x minus 3y equals 1. Okay, but I'm going to take this y and I'm going to substitute it back in right here. So that'll give me 2x minus 3 times 5 is equal to 1. So that'll give me 2x minus 15 is equal to 1. Then I would add 15 to both sides. So I get 2x is equal to 16. So then when I divide both sides by 2, I get x is equal to 8. And this is the other solution I was looking for. I could put them together and say that my solution is 8, 5. So this is the solution to number 7. Alright, take a look at number 8. Now, 12 is a multiple of 2, so I could make the x's into opposites that cancel. 15 is a multiple of 3, so I could make the y's into opposites that cancel. So for this problem, it really doesn't matter which one I do. I'm going to go ahead and focus on the y's this time. It's just really just arbitrarily picking the y's. I could have picked the x's just as easily. So what would it take? Here I have -15. Imagine that I were to multiply the top equation by 5. 5 times 3 is 15. So then I'd have 15y and -15y. I will have opposites that cancel. Let's do it. So if I multiply the top equation by 5, and please, you need to multiply all three of these things. The most common mistake I see with this method, students will forget to multiply the constant. So I should have 10x plus 15y is equal to 15. And then the bottom equation I did not change, so I'm just going to recopy it the way it is. Okay, now I have my opposites that cancel. So I'm going to combine these equations. These cancel out just like we planned. And now I have 22x is equal to 11. So if I divide both sides by 22, that's going to give me x is equal to 1/2. Alright, so that's one of my solutions. Now I need to take this and substitute it back into either one of the two original equations. I'm going to use the first equation, but it really doesn't matter which one I pick. And I'm going to substitute this value in for x. So that's going to give me 2 times 1/2 plus 3y is equal to 3. Now, 2 times 1/2 is the same thing as half of 2. Half of 2 is 1. So now I have 1 plus 3y is equal to 3. Subtracting 1 from both sides, now I have 3y is equal to 2. Time to divide both sides by 3. So I get y is equal to 2/3. Now I could write this solution as an ordered pair by saying the solution is 1/2 comma 2/3. So this would be the solution to number 8. Let's do one more example, number 9. Now, do you think I'm going to cancel out the x's, or do you think I'm going to cancel out the y's? What do you think? Well, look at the bigger number and the smaller number. Is 5 a multiple of 2? No. Is 6 a multiple of 3? Yes. So I am definitely going to target the y's. Let's make these into opposites that cancel. So look at the smaller number. I've got this 3. I want it to be 6, so it will be opposites. Imagine I were to multiply by 2. 2 times 3 is 6. I would have opposites that cancel. Please remember to multiply all 3 terms by 2, including the -7, which often gets left out and forgotten. So this will give me -4x plus 6y is equal to -14. The top equation is unchanged, so I just recopy it. 5x minus 6y is equal to 10. Alright, combining the two equations, those cancel out, of course. So that's going to leave me with x equals -4. Okay, so that's one part of the solution. That's my x value. Now I just need my y value. So I could pick either one of these two equations. I'll just use the first equation. 5x minus 6y is equal to 10. Now that I know that x equals -4, I can take that -4 and substitute it for x. So this will be 5 times -4 minus 6y is equal to 10. So that's -20 minus 6y is equal to 10. Then I would add 20 to both sides. So that's going to give me -6y is equal to 30. Time to divide both sides by -6. That's going to give me y equals -5. And that's it. I have my x and my y. I could put these together into an ordered pair. So in that way I could think of my solution as the point -4 comma -5. So this is the solution to problem number 1. Hey guys, that's going to do it for this video. Go ahead and click over here to watch the next video, and click over here to subscribe. That way you'll get every new video delivered right to your home screen.